So as we go on to part eight, if I convince you that risk analysis in the Sacramento Valley is not straightforward, but like I said, I think there's a lot of interesting challenges. And again, in all these cases, there's been ways to use the analysis tools and FDA to still compute expected annual damage and to complete the information that's needed for various flood studies. Well, so back to kind of the complexity of the levee system, and as I mentioned, our many streams. Another angle that makes the analysis difficult is the fact that in some cases we could be flooded by various different streams. For example, this area is called Reclamation District 784, and in 1986 it was flooded by a failure off the Yuba River. And then in 1997, it was flooded by a levee failure off the Feather River. And so one of the challenges is, how do you represent flood risk in an area like this? That initially a single index point was used, and that index point was assigned to the impact area, and we developed our interior-exterior relationship and computed expected annual damage. But the challenges with that is, what do you do if you're looking at improvements on a levee that doesn't have that index point on it? It's harder to reflect the change in levee fragility curve, or how do you really know what index point to pick? And that could change under various alternatives and conditions. And so it's really a challenge of, what do you do? Again, if you're using, for example, HEC Watt, you can do a fully integrated sampling and include all that. But absent that, it's not such a straightforward process. And so I want to talk a little bit about, what we did one time and kind of how we've refined that and done it now. So first, we thought, okay, well, we need to consider multiple index points. And so we first took our area and we said, this area can be flooded by a levee failure from index point 1, index point 2, index point 3, index point 4. Let's compute flood risk individually, uniquely, from each of these index point impact area combinations, and then weight all those damages together. And so, and that's what we did. We actually computed EED from index point 1, index point 2, 3, and 4, and then used kind of a weighted average based off of the level of protection, the annual exceedance probability. So we want to give a weight to the area that is the highest flood risk. We thought that EAD should be the highest, and that way we can account for the fact that we have varying sources of flooding, and the flood risk can really vary from point to point. What we do now is a little bit more sophisticated, where we say, let's really look at the underlying correlation of the hydrology and hydraulics. So again, we still compute flood risk from each combination uniquely, but rather than trying to do some weighted average, we look at the correlation of the flooding and the hydrology and fold that into the way that we combine and compute that single expected annual damage for the impact area. And then we compute the EAD with that, and then we determine the annual exceedance probability with that as well. There's actually a paper that we'll make reference to, again, an ASC journal article that kind of goes into some of the more details of how that process was computed. Well, I don't know how many of you know this gentleman, but his name is James Carville, a political pundit, and he was really famous in for a lot of things, but it was in a movie, The War Room, which was about how to get President Clinton reelected. And in that movie, and one of his big sayings was, "It's the economy, stupid. It's the economy, stupid. That's the key." And we kind of put this slide in here as kind of a reminder that it's not always just the economy. That sure, it's important to look at expected annual damage to structure and contents, but it's also important to consider life safety and consider statistical lives lost, and look at that the life safety aspect of the risk analysis. And so that's actually what we've done in the Central Valley, where just as we have developed detailed inventories of structures, we developed detailed inventories of population. So based off warning times and census data, assign people to structures, the residential structures, use information out of HEC-FIA, so information about given a certain water salvation, what the percent chance of a fatality would be, and folded that directly into the risk analysis and compute expected annual fatalities. So like I said, the first step is to develop that inventory of the population. And then within the FDA interface, rather than putting a structure value, we're putting a persons per structure remaining at the time of the flooding. And so we've already taken into account the flood warning time in that. And like I said, then fold into FDA again, instead of the depth percent damage of a structure, depth percent mortality relationships that come out of HEC-FIA based off a lot of research from Professor Yonkman and studying of New Orleans area. And so there's a way we're actually more explicitly including life safety into the analysis and able to report right next to our expected annual damage, our statistical lives lost. So it definitely is, we're not to say the point where, even though other federal agencies are monetizing what you're willing to pay to avoid a statistical lives lost, we're not, many of the studies not going that far yet, but showing, under various levee fixes, the improvements of channels, widening bypasses, how you reduce the flood damage, but also how you can reduce statistical lives lost. So again, it's not all about the dollars.